Hello all. So in the last session we were talking about central tendency and variability. So when we were talking about central tendency, that actually gives us the measure to identify the center value. Okay, so we have three measures of central tendency: mean, median and mode. Basically we use central tendency to identify the data, the values in the data as one particular value. Apart from that, we've also seen variability, which will actually measure how spread the data is. So today in this session I would be covering about finding the percentile, interquartile range, box plot, outlier and whisker plot using sample data set. So when we were talking about variability, okay, so we have seen central tendency will actually tells us where does all the points lie, okay, or the mean value or a middle value or most frequently repeated value, whereas we have seen variability will summarize how far apart the values in the data set are placed. Okay, so both central tendency and variability actually plays important role in understanding the statistics of the data. So we have also seen low variability is ideal because all the data values are put at one particular place, that is normal distribution is done when we have low variability. When we talk about high variability, which means that the values are less consistent and they're spread apart. Okay, so when you have high variability, it is difficult for the machine to make the predictions, right? So data sets can have the same central tendency, but will have different levels of variability or vice versa. Okay, so let's take an example of variability in normal distribution. If suppose we are investigating the amount of time spent on phone by different age group of people. Okay, so I have three samples here: high school students, phone used by high school students, and then we also have college students, and then adult full-time employees. Now when I take the statistics into consideration and plot a distribution graph here, as you can see, I have these three plots. Okay, the sample A, sample B and sample C, the minutes versus the probability. Okay, so all three of our samples have the same average phone use, that is approximately, the average phone use is around 200 or 195 minutes. Okay, but when we look into the x-axis value, that represents the minutes used. Although the data follows a normal distribution, each sample has different spreads, that is sample A has different spreads, sample B and sample C has different spreads. Okay, now when we look into that, observe sample A. Okay, sample A, that is the blue one, that has largest variability. Why am I calling it as largest variability for this blue line? The data is spread from beginning to the end. Okay, so when you talk about C, sample C, that is this yellow line. Okay, it has the smallest variability, that is the data is not spread across all the values of X. The data is available in one particular space. Okay, so we generally prefer low variability because the data is not that spread and it will be easy for the machine to make good quality of predictions. Okay, now let's talk about other terminology associated with central tendency and variability in statistics. So first we'll discuss about percentile. Okay, percentiles divide the entire data set into 100 equal parts, indicating the value below a certain percentage of observations which falls under it. Okay, for example, you can define 20th percentile of the value data set, or 50th percentile of the data set, or 75th percentile of the data set. Okay, now next talking about range. Okay, so range is the basic measure of variability when we talk about variability, or how far the data is spread. Okay, so this range comes into picture. This is basically defined as the difference between the maximum and minimum values in the data set. Okay, when we talk about variability and when I talk about how the data is spread, we consider the minimum value and the maximum value and the difference between each value amongst them. Okay, so the range actually indicates the difference between the maximum value and the minimum value. Okay, so the range gives a sense of how spread out the data, but does not provide any insights of the distribution. Okay, just the minimum and maximum, what is the starting value and what is the end value. Okay, now when I talk about interquartile range, this is very important. Interquartile range is actually a measure of statistical dispersion and is calculated as difference between third quartile and first quartile of a data set. Okay, so as you can see, I represent IQR as Q3 minus Q1, where Q3 stands for third quartile and Q1 stands for the first quartile. Okay, it actually focuses on the middle part. Okay, the middle part, that is the 50% of the data, and actually resistant to outliers. Okay, so first quartile actually means the 25th percentile of the entire data, and then third quartile actually means above 75. So when I exclude the 25 and below 75 and above, I am actually considering the middle part, that is the 50th percentage of data which is actually available in the middle. Okay, so that is your interquartile range, which is Q3 minus Q1. So note that Q1 is nothing but 25% of the data below the value. Q3 is nothing but 75th percentile, that is meaning 75% of the data and below that value. Okay, so this is very important when we talk about statistical analysis of the data. Okay, so first thing I was talking about range, which actually tells us the minimum value and the maximum value, and then we also have this interquartile range, which is Q3 minus Q1. So when we talk about statistical analysis of the data, so you need to remember this 5-numbered summary. We'll start with lowest value and highest value, which is nothing but the range. Okay, and then we'll calculate Q1 and Q3, that is 25th percentile and the 75th percentile, and then we'll also calculate the median. Q2 is called as the median or the middle value. So lowest value, highest value, middle value, Q1 quartile and Q3. Okay. So this 5-number summary will actually gives us visualization of the entire data set and how far the data points are spread in the given data. Okay. Now if we want to visualize this plotting, if you want to visualize the minimum value, maximum value, how far the data is spread, what is Q1, what is Q3, we go for box plot. Okay, for visualization we go for box plot. Okay, so box plot or whisker plot, both of them are nothing but the graphical representation of data that actually displays the median, the quartiles and the potential outliers, if any, in the given data. Okay, so the box actually represents Q1 to Q3, and the whiskers are nothing but they are extensions to this box, which actually represents the smallest and largest values. So if you have any outliers, they will be pointed outside the whiskers. Okay, let us also see how box plot is plotted. Just understand that within this plot visualization, we will have a box which will represent Q1 and Q3. Apart from this, minimum and maximum, that is the whiskers, are also represented, and also the outliers below the whiskers or outliers outside the box plot. Okay, so when we talk about the importance of box plot in machine learning, box plot will actually gives us clear representation of how the data is distributed, and we can also plot a central tendency. We can make easy patterns. We can understand the patterns of the data by using your box plot. Next, as I told you, within the box plot, whiskers are nothing but the extensions outside the box, which actually represents the minimum and maximum point. When we are talking about 5-point summary, we also have considered the range. Even in order to calculate the range, we want minimum value and maximum value. So apart from Q1 and Q3 quartiles, we also plot these whiskers, which are nothing but minimum and maximum points. Okay, so as you can see, this is your box plot for that particular graph. Okay, as you can see, these are whiskers, which are nothing but the highest value and the lowest value. Okay, and then we also have Q1, Q3, and we also have the median. So this is your box plot, and these are the whiskers. And if you have any outliers in this particular data set, I didn't have any outliers, that is the reason you're not able to see them. But if you have any outliers, they will also be displayed in the box plot. Okay, so the box and whisker plot are examples of the previous data set that we were discussing. Okay, so outliers are nothing but the data points that deviate significantly from the measure of the data. If suppose, as discussed in the example yesterday, when we talk about salaries of employees, if all the salaries, if I consider 10 employees, if everybody's salary is from 15,000 to 25,000, and if 1 or 2 persons have above 1 lakh, okay, so those 2 persons comes in, the salary of those 2 persons comes under outlier, because those values are deviated from all the other actual samples which are available in the data set. Okay, so if you have these outliers, they actually impact the model performance. Okay, so as the outliers are disproportionately placed, they will have different statistical analysis. Like as we have seen, the mean would be drastically changed if you have outliers included in that. Okay, so let us discuss this with an example. I have taken a sample data set with 50 numerical values. Okay, so here I have values starting from 12, 15, 14 to 50. Okay, so let's see how do we find the percentiles. Okay, so if suppose if you want to find 25th percentile or 75th percentile of this particular data set. Okay, so first of all we have to sort the data and calculate 25th percentile, that is Q1, P of 25, and then Q3, which is nothing but P of 25. Okay, this is the formula. If formula for finding the percentiles, K of n plus 1 divided by 100. Okay, so K is nothing but the percentile value, PK. okay, and then n is nothing but the number of samples. So P of 25 would be 25 into 15 plus 1 divided by 100, which is 4. In the similar way, when I want to calculate P of 25, it is 12, okay. So after we find out P of 25 and P of 75, the quartile values would be the value which is placed in this particular number, okay. So P25 position is 4, P75 position is 12, okay. So when I get back to this, so P4 I have 10, okay. So Q1 value would be 15 and Q3 value would be 35, okay. 15 and 35. Sorry, first of all we have to sort the data. So I have P25 as 4th value. So 1, 2, 3, 4th value is 15. Hence Q1 would be 15 and this is 12th value. 12th value is 35. Hence Q3 will be 35. Okay, first calculate PK, that is P of 25 or P of 75, and that would give the position of the value. Okay, so depending on that position we will find out quartile 1 and quartile 3, Q1 and Q3. Okay, now if I want to find the interquartile range, the formula is Q3 minus Q1. Here Q3 value is 35 and Q1 value is 15, so hence I got it as 20. Okay, similar way, if you want to create a box plot, first of all we have to find the lower whisker and upper whisker, and the formula for calculating lower whisker is Q1 minus 1.5 into IQR. Similarly for upper plot it is Q3 plus, so this is the lower one, right? Q1 below that, so Q1 minus of that, upper plot is above it, so Q3 plus 1.5 into that. Okay, so in this way you can also create a box plot. First of all, you have to determine the whiskers and then you can have the box plot summary. When we talk about box plot summary, the minimum value, maximum value, the Q1 value which we have calculated, Q3 value which we have calculated, and the median. Okay, so for this particular sample data set, this is the box plot that we have plotted. Okay, so in this way, we will first calculate central tendency and variability, which are two important concepts which work together in statistical analysis. So once you are done with that, if you want to have the visualization of central tendency and variability, we will go for finding the percentiles, we will calculate IQR, and then we will have a box plot which will actually give the statistical distribution of the entire data set, which represents minimum value, maximum value, mean value, Q1 and Q3. Okay, so understanding these concepts are actually crucial for effective data processing or data analysis in machine learning. Okay, so they'll actually gives us a clear understanding about how the data is distributed so that we can analyze the data well, and they'll also help us to detect and handle the outliers, and we can also visualize the data effectively. Okay, so this is all about statistical learning. Thank you.